All right, everybody, we're going to start a new lesson today on trigonometry and how trigonometry can help our game get so much more interesting. um, Trigonometry is a branch of mathematics involving right triangles and circles, and basically it lets us convert angles into kind of an x and y component. Um, we're using x and y components right now for lots of things, position and velocity especially. We have a vx and a vy for so many different things. But sometimes we get we get some interesting problems that this doesn't really help us solve. And so, for example, if you wanted to aim your gun at a particular target in your bullet, what would be the Vx and Vy to point it towards a particular place? So that requires us to do some cool math. Also, just in general, the trigonometric functions are great for planning out our levels. I'll show you an example. Here's a new wave that our launcher is going to have. It's going to make sort of an S curve of enemies that are flying down at us. And this is a kind of classic pattern that you'll see in these types of games. Again, a cool S curve going on. How the heck can you make something like this happen? So it turns out this S curve is based on the sine curve, although cosine would be just fine. This graph is a graph of something called the sine function. And the sine function basically oscillates between 1 and -1 as you kind of go around the unit circle. And now that I think of it, I bet there's a sweet animated GIF that shows shows how this is derived as an angle goes around a circle. Yeah, let me see. Can I find that in a short notice? Let's see. Unit circle sine curve GIF. Let's see if we can find it. Is this? Oh, I think that's the one. Let's see. So this is produced by. Oh, I don't think it's actually going to animate. Oh, there we go. Yeah, see, as this line goes around the circle, as we're kind of tracing out an angle, it produces this kind of behavior. And we can watch it again, probably. Does it restart? Yeah. There it goes. Just kind of goes around. And it's basically mapping the y coordinate of that line as it traces out the circle. And this is what we're seeing is the curve that gets produced as a result. So that's where the sine curve comes from. We'll talk more about how sine is derived and stuff, but that's a nice curve, and we can just use it for the curve's sake. So if we wanted to create a kind of S wave of enemies, what we can do is make our launcher kind of move in this kind of pattern, just moving kind of back and forth and produce that. So we're going to use a sine curve for this exact purpose. So let's take a look and see it in the code. So in my launcher, I now have, I just simplified it to launching things with an S-curve function. So previously we saw random enemies, straight line, two gunjips, and so on. So the S-curve we'll take a look at. It's going to make use of, actually I'll just mention before we go down there, it's going to make use of a new variable, and that's going to be angle. So I've added in float angle to our launcher, and angle will let us kind of go through that sine curve. If I can go back here for a second, angles is the sort of this axis here of the curve. And so as we trace out new angles, we'll get new values for the output, the height of this. So we can map that to the location of our launcher. So we'll go back and take a look. So here it comes. Here's the code for S-curve. So we're going to use the sine function to calculate. And actually, let me just take this out first. We can use the sine function to sort of calculate our x position. And as this angle changes, you'll see that we're changing it over and over again. We'll talk about that in a second. As we're changing it, we'll trace our way through the sine curve. So we'll start off at 0, and as you can see, when when the angle is 0, the sine curve will return 1. And as we trace through it, the x value will get mapped to this curve. So it'll go increasingly lower and lower to 0 when we get to 90 degrees. And then it'll go to negative, and so on. And so we'll end up getting this sort of this pattern. Eventually, when we get to 180 degrees, we'll bottom out, and then it'll come back. And we're going to sort of turn this 90 degrees to the right. And we're going to have this, instead of being the y-axis, we're going to make this the x-axis. And that's why we are assigning x equals sine angle. And if we just do it this way, and of course we're going to add enemy every 10 frames. If we just do it this way, it'd be pretty boring. Check it out. This is what happens if we don't have any other additional stuff. We just get enemies down here if we're just using sine, which makes you wonder, like, what the heck is sine doing anyways? The answer to that story is, why are we only getting a straight line? Notice the units here. I'll zoom in. The default sine curve returns a number between 1 and -1. And that's almost nothing for our game, right? 1 and -1 is the difference of like 1 pixel. So if we're looking at using that sine curve to map things to it, we're just wobbling by most between 1 and -1, which is a difference of 2 pixels. So we gotta like amplify this a bunch. We gotta expand it. So we're just gonna multiply it by a number. If I multiply it by 50, for example, you'll see it goes between 50 and -50. And so we'll see that kind of come out to 50 and then back. And notice how it goes off the screen. Whoops, it goes off the screen, and that's because it's getting into negative. It goes up to -50. Remember that the sine curve goes between 1 and -1. So if we multiply it by 50, we'll go between 50 and -50. So, how do we get it to stay on screen? Well, you could just add a number to that. You can just shift it over. So, I can add width divided by 2. That'll shift it to the middle of the screen. And then we'll see that oscillation happening between plus and minus 50 of the center line of the screen. We'll see it sort of going in between that. Now, if you want the S-curve to like expand the whole way across, you can just multiply this by half of the screen's width, right? Then we can go plus or minus half the width. And if we're centered, that's going to take us to the various edges of the screen. So width divided by 2. Let me think about my bed mass here. I think that checks out. Yeah. So that'll give us that nice pattern there. And you can try you can try a cosine and see how that differs. In fact, you can have some fun with that. A cool thing to try and get to happen would be a double helix. So you could have sort of, while this launcher gets to this side, you can have a second launcher that comes from the other side and gives you sort of two opposite mirror image S-curves that will look like a double helix, which is just all sorts of fun. So hey, we can use all sorts of functions, by the way. The sine wave function is, or the sine function I should say, is basically, it's basically just one of many functions that we can use to map things to some kind of movement. So we're going to move on now to look at other uses of trigonometry. Let's take a look at our gunships. I'm going to put our gunships out now. I'm going to say, where is it in our launcher? Here we go, SCurve. Let's put the gunships out again. This is called 2 gunships, I think. 2 gunships. Yeah, okay, let's launch this. So I've changed my gunships now, and they are going to aim at me. They're going to shoot at me. Oh, and that's fantastic. I think this will make for a fun game if things can shoot at you. So there's a bit of a lag because they're shooting where I was when the bullet was launched. So if I stay still, they'll definitely target on me perfectly. But as soon as I move, that bullet, when it comes out, it took time for it to get to me, right? So that'll be good. And that creates a bit of a space for maneuvering. You can create some sort of pattern where you're just dodging out of the way and never getting hit and so on. So that can make for a pretty fantastic game. So to do this, we are going to be doing something called Arctan. So let's go to the gun, the enemy, sorry. Yeah, check it out. This is the gunship. I've just modified it, and its act function is going to have some new fun stuff. So what we're going to be doing to make this aim is that we are going to be calculating the angle to aim at. So arctan 2 is the function we're going to be using. Atan 2, I guess you could call it. Atan means inverse tan, and it's basically a function that if you're given two sides of a triangle, it'll return, of a right angle triangle, it'll return the angle. So what we're doing is giving it basically a vertical and horizontal component, and it's going to calculate the angle out of that. And what it's really calculating is the angle to point the gun at the player. So this Atan 2 stuff is calculating this angle. I'll just stand still. They're calculating the angle to aim the gun at the enemy. Well, I guess at the good guy, which is me. They're the enemy. So they're pointing it this way. And once we have the angle, then we can use the cosine and sine function to break that into a Vx and Vy. That's the whole story right there. Cosine gives you x values and sine gives you y values from a given angle. And I won't be able to do this justice in the video, so in class I'll show us more about how that works. It has to do with sort of the definition of what the sine function and cosine function, what ratio of sides they are, and we're going to kind of just manipulate these equations. So we'll talk about that more in class. I think I need to draw on a whiteboard. If you're watching from home, you'll want to come in and ask me once you get back to class on this. But basically, we figured out the angle. The way that arctan 2 works is you need to give it Atan 2, you give it the target y, the target's y, minus the shooter's y. That's the first component. Y goes first. Don't ask me why, it just does. And then the second component, I'm regretting this, I'm going to put this down here. The second parameter is going to be the target's x minus the shooter's x. And this will basically give you the angle from the shooter to the target. What angle does the shooter need to turn to point at the target? So that's the format of Atan 2. And yeah, that's not so bad. So we're shooting at the player, right? So we have the player's y minus our y, the enemy's y. That's the enemy is shooting. And then same for the x, is target minus shooter. And then we calculate the Vx and Vy with cosine and sine. It breaks it down into its components. And then we send that calculated Vx and Vy to the bullet's constructor. And it creates a bullet that goes on the right path. I'll show you some other stuff. So that's good. We got enemies shooting at us. Let's go to the gun class. I made a couple new guns. Actually, I'll just show you what they look like first. We have a 360 Noscope gun now. Actually, I wanted to change this a little bit, but I guess we won't. So this gun is going to shoot a bullet. I think it shoots 180 bullets in those directions. You see, it just shoots a ring of bullets, and it's pretty powerful. It decimates the opposition. It looks pretty fun. So that's interesting. How are we getting these nice circular shapes? And of course, your enemies can make this happen too. Another gun is the turret gun. Around that, we'll see you can make a gun shoot at the mouse pointer. So I'm able to aim it. It's apparently just getting destroyed. If I had hit points, man, this would be a tough sell. But you can see the value possibly having a gun that you're able to aim with the mouse pointer. You can make guns that auto aim with this trigonometry stuff. You could do a lot of things. So how the heck am I doing that? So we'll start with some of the guns. The 360 Noscope gun. Basically, you use the same math, but it's going to change an angle. And I'm giving now. Oh no, I'm not actually. Every time I shoot. Here we go. Here's the 360 Noscope gun. It has pretty high threshold. If the cooldown equals the threshold, then I do all this math here. So what's involved in this math? So first of all, we have an angle, and this angle is going to go from 0 to 360 degrees. This uses something called radians to make this happen. So basically, it's not degrees. It's 2 pi is the 360 degrees equivalent in radians. Don't worry about it too much. We'll talk about it in class. So basically, this angle is going to go from 0 to 360, and each time it's going to change by 1 degree. I guess I send 360 degrees of bullets, 1 bullet per degree. So it's just going to kind of tick from 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees, all the way to 360 degrees. And each time it's going to make a bullet with a Vx and Vy that goes along that angle. And so what we do is we use cosine and sine to calculate the correct Vx and Vy. So let me just show you the components of this. First of all, this determines your range, so you can adjust things here. So if I was to make this just pi, that's 180 degrees. Let's see what that looks like. Oh, wrong gun. Sorry. Let's put on the 360 Noscope. You might notice that I'm using the word 3 as opposed to the number 360. You can't have a class that starts with digits, so you have to use words. Noscope. Gun. So let's see what happened if I change that one thing. So now I'm going to get, oh, look at that. It's going backwards. So this is not particularly useful going backwards. So you might wonder, well, where is that angle going? So it's just tracing itself out across. It's a little bit different than standard position in math. Let's go back to the gun. So, you could adjust things if you wanted to. You could maybe subtract from the angle. And so you can go around the other way, around the circle. Oh, uh-oh. I've had some kind of crash occur. I'm not too sure what I've done. Oh yeah, I guess you can't subtract, can you? Because that means you'll have an infinite loop. This will never get to the point. So you have to be like greater than negative pi. Yeah, I don't know. This is getting a little bit complex. Well, it's greater than negative pi. Yeah, and subtract. It's probably an easier way to make that go forward. You can kind of play with those things. There we go. Now it's going forward. So that's one example of how you can sort of alter things. Another would be, what about this number? What does this number do? So this is sort of the hypotenuse of our triangle, and it's basically the speed of our bullet. So if I make this 20, the bullets go faster. If I make it 5, the bullets will go slower. So let's just see what happens when I have it at 5. You can see the wave of bullets propagates out much slower as a result. So you can kind of adjust those speeds. I'll make it 20 just to see the difference. So this is sort of the speed at which the bullets are moving. So that's much faster. All right. The next thing I'm going to change, actually I'll put it back to 2 pi. We'll just leave it like that. If you wanted to have more space between the bullets, you could just increase or in this case decrease the angle by more. Pi over 180 is 1 degrees, so if I wanted to go up by, say 10 degrees, I could just divide by 10 less. So I could do pi by 18. You can just kind of play with this number. This is how big the angle is between. So you can see there's fewer bullets now because between each bullet I'm adjusting the angle more. If I did it by 90 degrees, that's pi over 2, then we'll get it going out in all 4 directions, which could be a pretty cool gun, but at the moment a little underpowered. But that's okay because I have no hit points, so I'm immortal. So, just need patience. So this is how much the bullet amount changes each time. So that's a pretty sweet thing to change. Otherwise, everything else stays the same. I guess you could change this number as well and start at a different place if you didn't want to start at the same place every time. So yeah, I'm going to switch it back to pi over 18. I think would be pretty sweet. I like the looks of that. So 360 all directions and sort of sending out this wave of bullets. Looks good. All right, last but not least is a turret gun. I'll just equip the turret gun really quick. And the turret gun uses the same stuff that our gunship uses, the ATAN2 function. So if we go to the turret gun, it's just using ATAN2. It calculates the angle between the target minus the shooter's Y, so the target is the mouse, the shooter is the player, and then the target's X, the shooter's X, the difference in that. That gives us the X coordinate. So it just calculates that angle. And again, we use cosine and sine to extract the Vx and Vy components. And then we just send it as our Vx and Vy. And that way we can get ourselves aiming at a particular point. You don't have to aim necessarily at the mouse pointer, by the way. You can think of, possibly think of other things to aim at. But it gives us a nice direction there. I'm shooting at the mouse pointer. Over here, shooting at the mouse pointer. You have to be pretty agile to be able to aim with the mouse pointer as well as flying around. Might make for a pretty fun thing. You just kind of put your mouse on the target you want. If it's a stationary target anyways, that seems relatively reasonable. So yeah, that's another possibility for interesting things to do with trigonometry. I think there's a lot of other possibilities of things we can do. For example, having enemies that aim towards you. That's going to be an example of ATAN2. Just like our bullets can aim towards things, spaceships can aim towards things. They can calculate their Vx and Vy and angles between things as well. So think about ways you can use this awesome trigonometry math to enhance your bullet hell game. Okay, thanks everybody.